Hello students, so today we are going to learn how actually a compressor works and what are the different types of compressors. So the objectives and outcomes are listed to understand the components in compressor, and after this session what is expected, it is you will be able to list and identify the components in the compressor, why there is a need of some components in its working, and also you will be able to differentiate between the different types of compressors. Now this is an image in which they have listed different types of components which are used for the compressor. So here you can see that this is a pressure switch. Start with the pressure switch, a new pressure gauge is there, then connecting hose. From here I can take the output. Here there is an inlet filter provided, a motor, a cylinder with a piston, a crankcase, a tank, a water tank drain. Now let's discuss in detail. What is the purpose of inlet filter? Actually, when we have learned the basic pneumatic system, we have already gone through this, okay. But just to repeat, this motor is provided to operate the crankcase, okay. If we take a piston type of cylinder compressor, so it will be operating the pistons. Forward reverse stroke will be given by the motor, so it is motorized. What is the purpose of inlet filter? The compressor is going to compress the internal air from the atmosphere, taken from the atmosphere, and it will be delivering it to the tank, and it will stored into the tank. So for that purpose there will be dust, some other particles which we don't want into the piston, inside the piston, which may block the inlet and outlet valves, even it can damage the piston heads. So to avoid all this we are using inlet filter. Then we do have a pressure switch. So pressure switch is, if at all there is some pressure set, that is we are providing set pressure, after 4 bar pressure the motor has to immediately shut down. Okay, so if this is the case, this pressure switch will take care of. Pressure gauge, it is just for indication that how much pressure is there in the tank. Okay, this isn't just brief because we have already discussed in our second topic. Let's move on to here a bit animation is shown. Okay, so animation I mean to say, see, in that there was just a crankcase and all that. Okay, so what is actually a compressor? So see, here the air is taken from this filter. This is an air filter, and this is the piston, crankshaft piston. So at the downward stroke, what happens? This is the inlet valve, this is an outlet valve, and they are being spring loaded. Yes, so air is being taken inside, it is at the downward stroke, and when it is moving upward, the air is compressed and it is pressing this, and the air, compressed air, the pressurized air is given from this part to the second cylinder. So we call this as a multi-stage compressor. We are going to see in just coming slides what is multi-stage compressor, but this is the middle part. Now what is this middle part called and why do we need it? So the name of this component is, it is a cooler. Okay, it is called as cooler. So what is it going to do? It is going to cool the temperature of the air which is being compressed, because when we are reducing the volume and increasing the pressure, at that time the air is getting hot. To avoid any problems in the mechanical system, the mechanical parts, we actually cool down the system, and so it is called intercooler. It is also called cooler or intercooler. Intercooler because it is in between these two cylinders only. Okay, and after this the cooled air is again given to this cylinder. The volume of this one is higher than that of the second one, that is a multi-stage compressor, to just increase the power of the air. It is going to give the air here again the suction compression stroke, and these are again the inlet outlet valves. So this is called inlet valve, this is called outlet valve, and to the spring actions they will be opening or closing based on the spring tension. Okay, and the compressed air is then stored into the air receiver tank. So if you could see, this is an on off button. So what is this provided for? This is only provided to operate this motor. Once I press this start on, the motor is going to start and it is going to drive this crankshaft. Okay, so this was about just a brief and revision of the compressor working. Now let's discuss what is a multi-stage compressor. So multi-stage compressor, that means the air is cooled in 2 stages. So this is, if you could see in the figure, this is an inlet side, this is an inlet valve, this is also an inlet valve, this is outlet valve, red in this. This is called intercooler, which we have seen a metallic part in between these 2 cylinders. So this is a first stage compression, this is second stage compression. These are the connecting rods driven by the same motor. If I just go back one slide, see, it is being driven by the same crankshaft, yeah. So the same is shown here, driven by the same motor. Now what happens? The inlet air is taken in, it is being sucked, then again to the upward motion. During the upward motion it goes up, it is compressed and it opens this valve. It opens this valve, it moves to the intercooler, and at the time it goes down, it compresses and again is fed to the outlet. This is provided only and only to increase the pressure at the output side, to increase the pressure. Okay, जो pressurized air होती है उसका power बढ़ाने के लिए ये multi stage compressors use करते हैं. Now let's move to the second. This is again the same piston type of compressor, but just to explain you how it actually works, I have taken this image. Air is taken in, you know this is an inlet valve, this is an outlet valve. What is this? So this is a spring. Yeah, this is a spring and this is also spring. So these are pre-tension. Pre-tension, that means इसके अंदर जितना pressure बैठ सकता है, जितना volume बैठेगा, उतना ही pressure compress या expand होगी. So when I say that air is taken in and it is this crankshaft is being driven by the motor, at the downward stroke, the air will be taken in. Yes, it is taking in. And after the reverse, that is upward stroke, what will happen? Due to the pressure, it is being closed, and due to this pressure from inside, this valve gets open and the air is taken out. Okay. So this is how a piston type of compressor works. For better understanding, actually already I have posted the animated videos of this piston type of compressors. We should go through that even. The next type of compressor is diaphragm type of compressor. So what is there in the diaphragm type of compressor? The mechanism to operate the valves, inlet and outlet valves, is only the difference. That is, here there is a diaphragm. Yes, it is a diaphragm. And this diaphragm is going to move up and down and open the inlet air and outlet air valves. The rest, it is also having a piston, it is having a hydraulic fluid. The fluid is provided so that due to the pressure of this hydraulic fluid, the diaphragm will be moving up and it will take the air in and shift the air out. Actually, this type of compressors are used whenever there is a small capacity requirement. Yes, only then we use the diaphragm type of compressor. Then the contamination is undesirable in food, then chemical processes, industries, farmers, and in that time I use diaphragm type of compressor because there is no oil allowed. Okay. Now so this was in just short about the diaphragm type of compressor. The rest is same. Yes, at the downward stroke the air will be taken in and the air inlet valve will be open. At the upward stroke the outlet air valve will be open and the air inlet will be closed and the diaphragm will move out and the compressed air will be taken to the cylinder. Okay. Now the next type is called screw type of compressor. The name itself explains everything. So these are the two screws, they are intermeshed together. What happens when they are being driven by the shaft? So when they are being driven, the inlet air is being sucked inside and the air goes in, it will be due to the volume reduction, the pressure is increased and at the outlet I do have a high pressurized air. Nothing different. सेम दैट ऑफ पिस्टन. ओनली थिंग इज एयर को अंदर लेना है, उसको किसी कारणवश उसका वॉल्यूम जो है वो कम करो. वॉल्यूम कम करोगे तो उसका प्रेशर बढ़ जाएगा. प्रेशर बढ़ेगा, दैट इज व्हाट इज एक्सपेक्टेड इन द कंप्रेसर. ओनली थिंग इज मैकेनिज्म. नाउ इन दिस दे आर यूजिंग स्क्रू टाइप ऑफ कंप्रेसर. I mean, this the contact between these two meshing surface is minimum. Hence, if we use for the screw type of compressors, there is no need of any cooling requirement. Okay, now I think this is much more sufficient for screw type compressor. Let's talk about vent type of compressor. This is another type of compressor. Okay, now let me explain this in detail. That is, these are what called as vents. This you could see, these are the springs. These are also pre-tension. This is an inlet side, this is an outlet side, and this is a housing. If you could closely observe this housing is eccentric. So these vents are eccentric. Eccentric, I mean to say, they are not centralized located. Why they are not centralized located? Because we want to compress. If it would have been at the center point, what will happen? All the compartments will be of the same size. तो फिर कॉम्प्रेशन होगा कैसे? कॉम्प्रेशन कब होगा? जब वॉल्यूम रिडक्शन होगा. वॉल्यूम रिडक्शन कब होगा? जब कंपार्टमेंट छोटा हो जाएगा. So in this case what happens? Now this is again driven by a motor. The center part is driven by the motor. It starts moving. Air is taken in. So this is the air taken inside, and as soon as it rotates, this vents adjust as per the direction. Yes. So the same part, if comes here, what is happening? The volume is reduced and the high pressurized air is given to the outlet. Only thing is volume reduced. P1 V1 is equal to P2 V2. That is if pressure increases, volume decreases, and vice versa. So this is what is called vent type of compressor. Now this one is called as a lobe type of compressor. Okay, so lobe type of compressor, that means these are the two lobes. Yes, जो हम लोब उठाते हैं ना हाथ में भी, तो सेम है. इसका सिर्फ क्या है कि जहाँ पे we need very high volume. वॉल्यूम ज्यादा चाहिए लेकिन प्रेशर कम होगा तो भी it will do. So in that kind of applications we use a lobe type of compressor. So it's by mistake screw type, it's a lobe type compressor. And in the lobe type compressor, actually what happens, this is driven, this is also driven. So what happens, there is some leakage. तो जितना आगे भेजना है ना वो पूरा जाता नहीं है, there is some leakage. And so where there is leakage allowed, you can use lobe type of compressor. And again the efficiency is also less because what happens, due to this intermeshing, the wear and tear is more. The number of more the components are moving, the more is the wear and tear. Okay, so to understand, to take the gist of this is, when we require high volume and pressure is lower, we can go for a lobe type of compressor. And what is the reference for this? It is Pneumatic System Module 6 and coldwater.com site. So this was all about from me. Thank you.